Well, hi everybody, and apologies that I didn't manage to get to example 3 in class today. So here's a video in place of that, and hopefully it'll cover everything if you need it. So let's have a look at example 3, which are what I consider to be more complex questions. We'll start with part A. I'll just do it over the side here. So in part A, I ask you to express y in terms of x. So I've got log base 9 of 3xy equals 1.5. Log base 9 of 3xy is 1.5, and I want to express y in terms of x. So basically I'm trying to get y by itself. So what I'm going to do is I'm going to start by removing the log. That's the outermost thing, and to remove the log I'm going to rearrange into exponential form. So remember, we've got this idea that log base a of y equals x goes to a to the power of x equals y. So of course that will lead naturally to 9 to the power of 1.5 is equal to 3xy. Now, I can evaluate 9 to the power of 1.5. You could do that in a calculator, or alternatively you could do it using your understanding of index laws. So I get this 9 to the power of 3 over 2 equals 3xy. 9 to the power of the over 2 bit is the square root function, so it becomes the square root of 9 to the power of 3, because that's 9 to the power of a half to the power of 3. So I'm kind of elongating this a little bit. You could do it a bit quicker or do it on your calculator. But the square root of 9 is 3, and 3 cubed is 27. 27 equals 3xy. Divide both sides by 3 and you get 9 is equal to xy, and divide both sides by 9 and flip it over and you get y is equal to 9 over x. I say divide both sides by 9 here, I meant by x. So it's a hyperbolic function with a dilation of 9, and there's not much more to it, just written in a different form. But that's an example of how you could rearrange a log function. Now we're going to talk about solving two equations that are a little bit more complex than usual, and how we might do that, particularly if we need to rely on technology, and when we might need to rely on technology. So the first one is 8 log base x of 4 is equal to log base 2 of x. So I've already got my concerns here. There's a couple of things concerning me with this question. X and 2, they're different bases in the logs, so that's going to make things a little bit harder. I can't combine them. There's not a great deal I can do here to remove certain elements of it. My second concern is that I have x there and I've got x here, and they're not both bases, so I've actually got x in two different places in the question. So we can have a play around with trying to solve this, but ultimately we're probably falling down a path of having to rely on technology, and that's kind of what I'm expecting that I'll need to do at some point. But let's have a little play. Some things we could do is we could change this so that we've got log of both, as writing that log base x of 4 to the power of 8 equals log base 2 of x. Now there is a chance that we could change the base of one of them. So if we wanted to change to an additional base, so for example this log base x, and you remember this hopefully, log base x of 4 to the power of 8, I want to write that down as log base 2 of something. Now let's say that I did want to make that change. Well, this becomes so just recall that if we go back up to the work we did earlier, we've got log base a of m equals log base b of m over log base b of a, and the proof is on the OneNote. You can have a look through that if you want to. So log base a of m, so I'll just write this down over here. Log base a of m equals log base b of m over log base b of a. So I want to write down log base x of 4 to the power of 8, whatever that is, and I want to write it down as log base 2 of something. So I'm actually going to set my b equals 2, which will involve some rearrangement. A equal to x, and m is obviously equal to 4 to the power of 8, and so I get this. And this is the left hand side, so I shall write it down here. Log base x of 4 to the power of 8 is equal to log base 2 of 4 to the power of 8 over log base 2 of x. So I get, this becomes log base 2 of 4 to the power of 8 over log base 2 of x equals log base 2 of x. Now multiply across that doesn't look much like a 2. Multiply across on both sides, and I get log base 2 of 4 to the power of 8 is equal to log base 2 of x squared. Now I'm actually pretty happy here because what's happened is I've got the x now only in one place. So what I'm going to do is I'm going to charge forward with this question, and we'll talk about the results of it in just a moment. But first I need to look at that left hand side and simplify it, because I see now there's only numbers there, and in fact 4 is a power of 2, so life's a little bit easier here. I'm going to change it to be log base 2 of 2 squared to the power of 8, elongating a little bit again, I apologise, and that becomes log base 2 of 2 to the power of 16 equals log base 2x to the power of 2, and of course this is 2 to the power of and log base 2, they're inverses, or I can bring the 16 out of the front and recognise that log base 2 of 2 is 1. Whatever you do, I get 16 equals log base 2 of x, and so therefore, oops, that's squared, my apologies, log base 2 of x is equal to plus or minus 4. Now 2 to the power of minus 4 works, and 2 to the power of positive 4 works, so I have to recognise there's two possible solutions. So x is equal to 2 to the power of 4 or 2 to the power of negative 4, which equals 16 or 1 over 16. Either of those solutions will make that equation work. That's a nice little result that didn't actually require the use of a calculator to solve. Interestingly though, if you did use a calculator to solve and you got a nice answer, it's worth considering, maybe not in an exam, but certainly in your revision, going back to see if you can solve, because a nice answer probably implies that you could have solved. And so let's have a look at the last question here, which is part 2. E to the 2x minus 3 equals the natural log of something, 2x plus 1. So there's another question. I suspect there may be some calculator work here. I've got my calculator ready just in case. But again, we might get lucky and there might not be. It's worth playing around with it. So what I'm going to do is I'm going to recognize that I could actually write this 3. I can't do anything with it on this side, but I can write it into the log over there. So watch what happens here. I get e to the power of 2x equals log 2x plus 1 plus 3. Now, what's the natural log of what is equal to 3? E to the power of what equals 3 is actually a pretty tough question, which comes out as being an irrational value, but I might be able to write it as a log. And then if I can write this in some nice format, I'll be able to bring this together. And in fact, I suspect I can by recognizing that log of e to the 3 is equal to 3. So I'm just bringing this in. This might not go anywhere, but let's just try it. So log of 2 plus 1, this is a natural log, plus log of e to the power of 3 equals e to the power of 2x. And if I bring those together, I get the natural log of e to the 3 times 2x plus 1, that's all inside the log, is equal to e to the power of 2x. So I've got it down to 2 terms, which means I could now rearrange it somewhat, because I get e to the power of 2x equals this stuff here. So I might actually remove the log and see what happens in terms of our exponential function here. So I'm going to create, I take out the thing that's in the log here, which is e to the 3 2x plus 1 is equal to e to the power of 2x. Okay, so that's a bit tricky. I'm kind of a bit of a crossroads now where I don't know whether I'm going to be able to solve this using anything but a calculator method. And it's just something I suspected earlier up here, and I'm just taking you through my thinking now. So I was already considering calculator because I had this e and this log, and you don't often see them in equations together. And it's kind of like you're dealing with something that's one step ahead of something else, and you can't really compute them together. It's not going to lead to a nice quadratic as we had earlier, and that's what makes this question a bit harder. So what I'm going to do now is I'm going to flick across to my calculator and show you how you might be able to solve it in there. So personally, I think it's important here, I'll just make this a bit bigger, to recognize that there are, I'm just going to make this a little bit bigger. I've made it too big, haven't I? There we go. There's a few ways of doing this in the calculator. So if I go into the run matrix, I can go into the equation solver, but the run matrix has most of what you want anyway. So if I go into here, I'll just delete that. There we go. And go into options and then calculate. I've got a solve n and a solve. So I'm going to use the solve n, and I'll just put in that e to the power of 2x. And I've got to make sure I use x on here, not on there. And that's equal to, no, that was minus 3 is equal to the natural log of 2x, and just remind me, plus 1. Solve that numerically, and I've got a syntax error because I did muck around with my keyboard. I suspect it's with the e that's not accepting my e. Just check the log function, that's not that. So what I'm going to do is I'm going to delete that e and use the actual e key on here. And then 2x, and let's try that. Okay, so I've got the many more solutions, which is always good, and it's suggesting a couple of solutions there for me, and neither of those solutions are nice numbers, but you can see the solutions that we get. So that's negative 0.463 and 0.674. So let me write those two down. I believe they were the two answers there. And my other option is to flick across into graphing mode. So I'm going to exit here and go to my menu and just go down to the graphing mode. I could use the equation solver, it'll give me the same result. But in graphing mode, I'll just get down. I'm going to start by unselecting those two, so I just have to press F1 to unselect. And in here, I'm going to type in and enter my two graphs. So the first one is, I have to use this key on here, e to the power of 2x minus 3, and that should automatically select. And the second one is log of 2x plus 1, and that should select. And I'll press F6, and that will draw it, although I've got a syntax error because I've typed in the x and not used the x button. Just check this one up here as well. Okay, try this one again. And there's my two sketches, and I can pull this up or use my V window to change the settings. So I want my X minimum to be, let's say, from negative 10 to a maximum of 10. And then I want to go down to my Y settings and make that negative 10 to a maximum of 10. I can see I just needed to go a bit wider. And then I'll draw that again, F6. And that's a little bit nicer. You see that this log function does finish suddenly, which might imply something about the function. But I can see there I'm pretty comfortable. There's two coordinates where they meet. If I click on Gsolve and then intersect, and it will give me those two coordinates. It takes a moment to calculate them. First one is 0.463, and I click across. The second one is 0.674. So there you have it. There's our two solutions there, and I might just go away and think about if there is any other way of solving that algebraically, but for now we can rely on technology with certain elements. And there's something for you to play with. Anyway, all the best.